Okay, so with that, I'll first invite Keyur from Pluto Man. Congratulations, Keyur. It's a very hard-earned win. I know it's been 1 month of a big kind of, and a lot of efforts have gone in. So many, many congratulations.
Thank you so much. Hello everyone, I am Keyur. Giving a brief about Pluto Man. We are a company which provides augmented and virtual reality solutions to enterprises. We have more than 6 years of experience servicing and consulting clients across various sectors on AR, VR, and MR. We try to focus on solutions which empowers enterprises to improve productivity, extend workforce capability, and enhance customer satisfaction. I thank you everyone, as in while the journey from giving the use case till the time the announcement of the result, it has again a great journey for us, learning few things and learning actually the use case which are driven by the industries that always help us to kind of I would say brush up our own solution on what we are talking about. The problem statement: the boiler manufacturing company requires a stringent quality check at multiple stages for the incoming material, be it at the factory or at the project site. It demands a skilled human resource to understand these parts, prepare and execute quality workflows for statutory requirements, record keeping, etc. This can create a heavy dependency on the resources and thus also leading to high cycle time and prone to human error. This process is manual, making it less intuitive and is also paper driven. So the objective here is to create a solution which can simplify this process. It can minimize the dependency on the skilled human resource. It has to be more intuitive. It helps in live reporting and analytics. And foremost, it integrates with the existing enterprise system. The proposed solution is an amalgamation of multiple technologies, wherein the prime tech is AR, but while it will be assisted with AI ML, 3D workflow instructions, and remote collaboration. The approach which we are planning is we will first start with the wireframing, similar to a storyboarding, where we'll understand the workflow, we'll decide on the before and after workflow, and then parallelly define the sketches for the technology front. We'll go after that on a POC, wherein based on the output of the POC, we'll proceed with a full-scale implementation. And while doing a POC, we'll work out the methodology. We'll also take an important decision on few of the steps, wherein how to scan the object, whether it should be a QR code or it should be a mix of AI, ML, and AR. And also we'll also take a decision how to guide and assist. So once the identification is done, how we can actually project things. So the checklist would be hover around the object, or it will be a separate 3D model where you can interact and see the technology which we are looking at would be on the front end. It will be iOS, Android, and Unity. On the backend side, the most important thing which we wanted to clarify here was that we currently are using AWS, but we are open to using it either if the company has Microsoft Azure or Oracle Cloud, we can definitely work around that. The visualizations, you scan the equipment, you can it can be a bigger equipment, it can be a small equipment or a part, and you will see pointers and the checklist coming near to that equipment. And there is also an option wherein you can see a separate 3D, wherein it can be also taken as a training module for people who are just a new hire or a lateral hire for the parts and the equipments which are the incoming materials. So, and the other part, while you are scanning and if you select on any one of the pointers, you can then enter the parameter of what you have inspected. While entering the parameter, you will have a guidance for what has been the trends, the data visualizations, and then you can take a decision of what needs to be done. In case you have a trouble of not able to take a decision or you are having any doubts, we are intending to add a module which is of a remote collaboration, wherein you can call the expert for help, and it can be an expert, it can be a supervisor, or any of the segment expert who might not be available at the same field. The success criteria here would be measuring the KPIs on the productivity improvement, on the time taken by the new hire to onboard on the routine work, before and after process work, wherein number of steps reduced, time reduced, the overall reduction in the rejected parts, and the output of the solution. Again, it's similar to what we were looking from the objective perspective, that is, it has to be tech-enabled, simplified process, cost optimization, minimizing the dependency, and on-the-job training. The timeline which we are looking for implementation of this use case for the POC, it can be 6 to 8 weeks. For the full scale deployment, it can be a 14 to 18 week time. Similar use cases, exact replica of what the use case is. The only difference is this is of maintenance, and the current use case is of quality, wherein here we are digitalizing the complete manual maintenance process, identifying the machine, checking for the maintenance schedule, selecting the checklist. The assisted pointer will be highlighted over the machine, and in case of any problem, remote expert can be connected. You can create, we are also creating a digital library here. Plus, there is a maintenance schedule which will be triggered. So similarly, for our inspection, it can be a, so let's say if they are nearing their shelf life, the inspection can be triggered. So those kind of similarities can be drawn, and that can help us in actually executing the project even better. The benefits here, the first and foremost, is democratizing the expertise. And because of that, it will help in minimizing the dependency, reduction of cost, and productivity improvement. The other similar case studies, this is one of our product, ready to implement product, again available as a subscription, wherein you can have remote assistance enabled with AR, which helps in collaboration between field service technicians and offsite employees. It benefits in technical expert not required at every location. It can eliminate your travel, on the job training, first time fixed rates, and it can also help in inspections from remote location. We have implemented this product across various companies like Sterlite, Reliance, Honeywell, etc. Machine AR, this is nothing but the first step towards digital twinning is first creating the 3D assets and procedures. So that is what we are good with, wherein we create a low poly model of all the assets. And once we have the low poly models, based on the use case, we can typically create AR based applications. It can be used for onboarding training, for digitalizing the manual, or maybe for the customer engagement, or whatever the use case is. Here for the use case, it can be more about creating the procedures and the assets of these parts and the equipments which are incoming, and then typically creating a training out of it, that how to inspect, what are the sub assemblies which we need to check, and when we talk about the checklist, what are the pointers which needs to be typically checked. So I think this is it. These are few of the clients where we have worked. Thank you so much. Looking forward to the collaboration, and thank you everyone again, and looking forward to work as a team.
Great. Thank you, Kayur. Again, congratulations and the best wishes.
Thank you. Thank you so much. Yeah.
Okay, thanks. Okay, let's move to the second one on the smart energy management use case. We have Praveen. Hi, Praveen.
Hi. Hi, everyone.
Hi, congratulations.
Thank you so much. Thank you so much.
Must be excited. I can see it on your face.
Absolutely. Absolutely. It's a great platform to be here, and we are excited just to be here. Pleasure.
Great. Okay, so should we share your presentation and you'll just go through, or you prefer?
Yeah, that's fine. I'm gonna I can share if you give me the right. I have a copy that will be because so that I can curtail it for 5 minutes. I'll accordingly.
Yeah.
I'll go ahead. Oh no, okay. Yeah, if you.
Go ahead. Yeah.
All right. So yeah, let me go back. Just introduce. So we solve the problem of reduction of energy consumption, cost of energy, reducing, and byproduct is reducing the breakdowns, machine breakdowns. So I'm not going to get into that. I'm just going to jump into the solution, how we solve it, and spend some time on how we take what's our technology and the metric. So that I keep check on my time. So. One thing I want to highlight here is that the data collection has to happen not only in input energy but also on the output, and that's what I'm going to define in next slide as well. So the steps that we follow, really our first is digitize the machines and the measurement devices on input and output both sides, because you really drive energy efficiency through the efficiency. So to measure efficiencies, you need output and input both parameters. So you install measurement devices. Then we have our IoT gateway, which is installed to pull the data, and it also give instructions to machine as well. So IoT gateway is installed. Hello, I can hear some noise. Okay, so IoT gateway then sends the Amit and Yagdeep. Can you hear me? Everything okay? Okay, so when first we run the simple analytics to benchmark the specific energy consumption. Now, any energy project has to be driven by specific energy consumption, because let's define this term here. Specific energy consumption is kWh per unit of product, or per kg of product, or per, let's say, if you're talking about a simple pump, per kiloliter of water. If you're talking about chillers, per tonnage delivered of refrigeration delivered. So you benchmark, you identify losses, root cause, do the root cause analysis, and come up with simple solutions that's going to be implemented. Then the next stage comes where you do deeper, where on this large volume of data that you've collected through digitalization and then our IoT gateway, data comes to 7 Intel Core, which is our core engine. There you run machine learning models and energy engineering to generate two kinds of actionable insights. One level is decisions which does not need a lot of capex. So, example would be some of the examples were discussed in the panel discussion and earlier as well, that how do you make sure that in between the cycles on and low occupancy even on your air conditioners or on your process chillers. These are some of the examples. Level 2 examples would be where you need capex, you need shutdowns. So those are typically projects. So let's say your furnace heat insulation is not effective. There are a lot of heat losses through the heat insulation. So insulation needs to be replaced. Those are also the level 2 analytics, that level 2 actions that come out of this entire program. The fourth step is really the implementation of these actions that can happen manual as well as remote. So setting up efficiency for your air compressor when the demand is low, so that the compressor runs at best efficiency point, even in low demand zones, we can even do remotely. A lot of things can be done remotely, and a lot of things you have to work with the ground teams to implement those actions. So that's the route we take, and we solve this problem using our product called 7 Intel. I've already talked about 7 Intel has it's deployed on the customer facility. It has our own proprietary software which talks to machines, sensors and meters, and collects data and also gives instructions both ways. Then this data is sent to 7 Intel Core, where the large amount of data is collected, and machine learning modeling is done, and energy engineering is also done. So both are applied on this data. Again, this is deployed on AWS. Our system, all of them are deployed as Docker containers, so you can scale it up as and when the requirement be. We use Azure ML Studio for machine learning modeling, and then the third piece is 7 Vision, which is our visualization software that can be viewed on any browser and any Android phone. So really, our 7 Intel architecture broadly depends on edge and cloud computing, and it harnesses power of IoT and ML. I know I'll just spend 1 minute on this slide, then I'll possibly kind of leave it for other speakers. So any energy conservation program, the key is you have to define the measurable KPIs, whether you do it manually or do it through a system like 7 Intel, because it's important for us to make pitches to the management. We define the ROI completely. That's why you define the metrics and you define the success criteria. So in business terms, success criteria that is defined is specific energy consumption, and some places they may even say INR per product, and carbon emissions. So energy cost, SEC, and carbon emissions. And the success criteria is all these three parameters should be on a reducing trend year on year, and ability to measure this objectively and improve it objectively. So many energy conservation programs fail because this objectivity cannot be achieved. With help of IoT and machine learning, we've achieved that to a large extent. Most of our projects we managed to our customers are pretty happy with this, that we've eliminated the entire subjectivity. Now we've deployed this in plants like L&T, in plants like Taj Hotels, and a lot of SME plants in and around Pune. So we already have some 30 plus installations. I'm going to skip these slides and go back, go to this one case study I'm going to talk about. This is air compressor where we implemented our system and our program. The specific energy consumption for air compressors is kWh per CF. That was improved 38% by using our system. We brought it to 0.18 from 0.29. Now, the key is conventional energy engineering tells us that performance of your air compressor depends on 5 parameters. How we made a difference using artificial intelligence and large volume of data that we got through our IoT framework is that we were able to identify that 5 parameters are important, but out of the 5, there's only one which has 85% weightage. And we were able to make a difference in that particular parameter, and it changed the picture completely. So our savings, which would conventionally be 15-20%, went to 38%. And this is the same. This is a thing that we replicated in all systems. We've done that in chillers. We've done that in hot water systems. So we have plenty of case studies. I'm going to stop here because of the constraint of the time. Thank you so much, NASSCOM, for this platform and industries. It was a pleasure to attend this program, and we're glad that we won it. Thank you.
Thank you, Praveen. Again, best wishes.
Thank you.
For actually working on the problem.
Thank you so much.
Okay, thank you. Okay, next we have Nagendra. Hi, Nagendra. Congratulations.
Thank you so much. It's been really amazing.
Yeah, I'm sure you would have kind of spent a lot of nights in coming up with this. I mean, because considering the nature of the challenge it was actually very tricky. Good job.
Yes, definitely. I completely agree. And I think our team here has put a lot of efforts, which made us to get this statement today saying that we are the winners. We're really happy. And it's the second time through NASSCOM. First time was with LG. We are AI partner for LG through NASSCOM. And this is the second time with RPG group through NASSCOM. So it's amazing platform. I'm grateful to the NASSCOM team.
Pleasure. Okay, so quickly, I mean, should we share your presentation or you prefer sharing?
Yeah, I can share, but I think host need to give the permission.
Okay, I've given you.
Yeah, thanks. I'll just quickly go through. I mean, probably not spend too much of time on that. The biggest strength of this organization is when I was listening to the great people talking about Industry 4.0, I was once on the other side, thinking as how AI can help, various industries to support, to grow in their own area. So what happened is when I was in such organizations, when I came out, I decided to start a company in AI ML. And probably this is a day where I feel good about what we thought is what is getting achieved. Radom Tech started in 2017, but we are a bunch of mechanical engineers with great industrial experience. Started this company as a sole entrepreneur to use and leverage AI applications. And we are already Defense India Startup Challenge 1 winner in AI applications, and the product is almost ready for deployment. And also through, as I mentioned, through NASSCOM, we are also a partner for LG SI, LG in developing AI solutions. So moving ahead quickly, as we all know the problem statement, so it was all discussed. So any tire missing the inspection going to the customer is a big pain to both of them. And so that's what we are trying to solve, and how to solve it is here. So we have completely given our thought in developing in-house complete solution where you will have the tire getting inspected through I would say a kind of a conveyor belt system where we have the capability of, putting a 360-degree ball transfer system. So once the tire lands there, and we have lasers which capture the profile of the tires from all 360 directions, and This profile is then used and analyzed using a software solutions, which is completely AI/ML based. So our company specializes in AI/ML, and we are already working with LG for an anomaly detection use case. So also we have the capacity to develop our own software along with the mechanical system to run the whole solution. Here the key aspect is profile, which is captured from the scanner, is exactly giving the anomaly, as well as we are planning to use the cameras. And if you can see, it can take your complete profile, edge, surface, all the technical aspects defined by the use case owner is being taken care by this solution. And this can detect a defect up to 12 microns at a resolution of 2048 points. So what's special with Redom Tech is the ML models which we develop in-house
Okay.
is our strength. So the actual profile of a good tire is taken up and then trained, and we have the complete expertise of training, testing, and deploying ML algorithms in the operational environment. We also have the capability of deploying the solutions on edge. We are also a partner for one of the US companies developing the edge devices to handle such high-speed inspections. So target for us, which we have kept, is the inspection accuracy should be more than 95%, and then inspection time we are targeting is almost 10 to 20 seconds, which is actually the milestone. I mean, it actually is our, I would say, benchmarking, which we have gone through the some of the people who have been doing this in the world. And defects handled, we are targeting 20 defects in phase 1, and phase 2 cumulatively 40. So escape rate we are targeting is less than 1%. And then timeline, we have phase 1 for 6 months, where we have the prototype and the complete functional product in 14 months. So to talk about the case studies, we have undergone the complete understanding that a German tire manufacturer is using these kind of sensors, as well as the camera, to extract the 3D profile of the tire, where 95% and above defects have been identified and taken care in the automated line. And it's a 3D profile. And if you see on the bottom of the screen, these we are already developing a particular solution for Indian Navy, where we are managing the health of an aircraft with more than 3,700 sensor data coming every second. So this is a kind of data we have handled and the accuracy we are targeting. So this is what we would like to offer to our the customer. And thank you, NASCOM. And I would like, through this, I would like to say thanks to all my team here who have made it happen to take the first step now. So the big challenge is ahead on the execution and delivery as per expectations. Thank you.
Great. Thank you, Nagendra. Okay, so yeah, you can stop sharing. Okay, so we have Akshata with us.
Hello. Hi.
Hi, Akshata. Congratulations.
Thank you. Thank you very much. Yeah.
No, thank you, man. I know it's been again a very tricky use case with so much complexity. Good job in kind of doing it. Great. So, would you like to share, or we prefer us to share your presentation?
You can let me in. Like I can share the presentation and take it up.
Okay, done.
All right. Okay. So I'll just begin. Good evening, everyone. I am Akshata from Pixel8, one of the co-founders. Thank you very much, NASCOM team and also Grasim team for helping us work through this use case and come up with a solution, hopefully, which will help solve the problem, that the statement which was shared to us. We are a Bangalore-based company. We specialize in AI and deep learning-based technology development, particularly in the space of images and videos. So we have developed multiple vision-related projects and applications. In the past, we have worked with customers like Unilever, Godrej, Big Basket, Opter, L&T on different applications, all related to vision space. And that's where we had also worked on a cotton yarn cone inspection system as well. So we have been recognized by the Government of India's Technology Development Board and Government of Karnataka's Startup Cell. We are also incubated and invested by IIM Ahmedabad's Incubation Center, CII. We are part of NVIDIA Inception program and also some other support in ecosystem support. Let me just go through the use cases and help you understand what we are trying to solve here. So basically, this is for the garment cotton yarn cone manufacturing sector, where there are thousands of cotton yarns, cones or spindles being manufactured, and there is a QC that is required to identify the defects at the last point, which is done manually currently, and they are looking for automating this process, where we are looking to solve using the vision-based application, identify defects such as dirt particles, pad binding, polyester mix, or a different material mix in the threads, also a defect in the paper cone as well, and any color variants. So these are the different defects we are looking to identify, and also segregate based on different criteria, be it weight, dimension, or paper cone color. So this is how the system will work. So we will place our edge computing device with our software, proprietary vision software, to do a 360-degree inspection on the assembly line inside a UV chamber. And then based on the input, if there is any defect, it will be separated or segregated based on the other segregation criteria which I mentioned. So we will be training our system and identifying various defect types. Also the cone types. We can work with both white threads or any colored threads, cones, and also work on further defects which the customer would have. So this is how the system is set up. And we use computer vision and deep learning technology, and we can integrate various other sensors, be it weight measuring scale or any other sensors that would be required to work on a certain throughput that the customer requires. Currently, we can work on a throughput of 30 to 40 cones per minute, which can be improved as well. We are planning to deploy this solution in a 3-month duration, starting with the audit and the site inspection, understanding the requirement, and then building a prototype, which would be a 6 to 8 weeks timeline, both for the hardware and software prototype. And then we can go ahead and deploy the pilot in the last month. So what we are looking to achieve as an outcome of the solution is a system dashboard, which will help the customer monitor individual conveyors or even a combined all conveyor results. The audit report will be available, where both rejected codes and criteria of rejection will be available. And so they will be able to both monitor all of this real time. This is a low latency model. All of the results is on the real time and at a high throughput as well. So we had implemented a similar solution previously, for a company in Coimbatore, and we have been able to achieve 0 false positive and a throughput of 30 cones per minute, and look to improvise the solution and build a very robust QC system for Gracia. So apart from this, as I said, our strength lies in doing custom R&D projects in the vision space. Apart from this, we also provide a wide variety of analytics for surveillance cameras, be it facial recognition or any other person detection. We also have a very robust vehicle analytics module, or be it safety gear checks or worker safety, and also a thermal camera analytics is what we do. So this is the other solution suite which we have apart from custom R&D projects. Thank you everyone for your time.
Great. Thank you, and best wishes when you kind of actually work on the POCs. I'm sure it'll be exciting. Great. Thank you. Okay, next we have Saurabh from Vashishta. Hi, Saurabh.
Hi, this is Saurabh. I'll just start my presentation.
Many congratulations for winning.
Yeah, and also I just
Yes, Saurabh, we can see you. Saurabh?
yeah, it's coming up.
Should we share the presentation?
Actually, I think I will switch off my camera. That's causing a lag. Okay. Okay.
Yeah.
Can you see my screen now?
Yes, we can see. Go ahead.
Okay. I think we'll just go ahead. So this was a proposal to MIC2 challenge for material volume identification using image processing by JK Lakshmi Cement Company. So this is a little bit about our company, and our aim is to develop indigenous manufacturing technology solutions, and we are good in the development of machine hardware, electronics, image processing, making 3D viewers and algorithms. Currently, we are developing a panel scanning robot, which you can see on the right side. It gives a 3D model of a panel using a line laser method, and these are actually used for the aerospace industry. We are working with ISRO for that. Also, a tender is awarded to us by IIT Palakkad, which also uses a laser sensor, and you can see it on the middle drawing. And we are also awarded Dare to Dream first prize by DRDO and Idea Grant by Kerala Startup Mission. So this is the problem statement. The first use case is for conveyor belt scanning. So some materials will be carried on a conveyor belt, and we have to measure the volume and surface area of that material, and they may be in a fine size or small powders. IP camera is located above the belt, real-time latency required. And the second use case is for stockpile volume estimation. Like there will be a big heap of a material. We have to estimate the volume and surface area and display it in a 3D viewer. So this is our solution proposed for conveyor belt scanning. Uses a line laser scanning method, uses laser triangulation. A line laser projector will be mounted above. It will project the line, and the profile will be captured by an IP camera, and we integrate this profile over time, we get volume, and we integrate perimeter over time, gives us surface area, and the belt speed must be known for integration. This algorithm is very simple and it will be very fast. It will operate in real time. For stockpile volume estimation, we propose LiDAR-based scanning solution. There will be LiDAR that is mounted. It will be scanning over the surface. It will be getting points on the surface, and from that point cloud, we can compute the volume and surface area. And once set up, it can be fully automated with minimum manual steps. LiDAR with servos, the hardware cost we estimated at around 25K, and the results will be displayed in a 3D viewer, which you can see on the left side. We are developing the 3D viewer for the panel scanning. This would be the success criteria and measurable KPIs for our project. The accuracy and precision of the volume, that will give us the how good our estimate is, and also the latency time. And this is basic timeline that we have. First is for the POCs, we have said around 2 months. Then accuracy estimation for that, so another 1 month, and then final development of software GUI, hardware modules, and then deployment another 3 months. And this is the case studies of similar products that are available in the market. So for conveyor belt scanning, there is Hyperion Systems, Vega, and LoadScan Limited. And for stockpile estimation, there is Laser Technologies, Lace Solutions, and Stockpile Reports. And most of these use the same techniques that we are proposing in our proposal. Okay, that's it. And thank you very much for giving us this opportunity, NASACOM and JK Lakshmi Cement Company.
Thank you, Saurabh. Great presentation, and best wishes for working on this use case.
Okay, thank you. And I will stop sharing. Okay. Yeah.
Okay, so next we have to give Prateek.
Yeah. Hello.
Hi, Prateek.
Hi.
Congratulations for coming up with such a innovative solution with the lock under 2500. Congratulations.
Thank you.
Okay.
Are you able to see my screen?
Yes.
Yeah. So our solution was for e-lock, cost-efficient e-lock for mother dairy, for an application of mother dairy. This is a profile. We are funded and supported by iCreate and Ministry of Electronics and IT. And we are a fairly early stage startup, and we are focusing on developing smart logging systems for various applications. We have experience of more than 3 years in consumer IoT domain, and we mainly focus on destroying costs while building efficient systems. So yes, this was the problem statement in which we had to nullify any chance of milk adulteration in container on wheels. It provides poor quality of milk to the customer, as well as reduces depreciates the brand image of mother dairy. Our solution would provide a durable locking mechanism with a proprietary double hinge mechanism. We'll be providing mobile app with access through feature phone also. The mobile app will have geofencing, on-demand tracking through GPS. We can get real-time alerts through the mobile app and embedded sensors inside the lock. And our solution will be extremely low power with a backup time of up to 3 months. And to top it up, the solution will be under 2,500 rupees. So this will be how the system look like. The onboard sensors on the lock, and how the authorized milk outlet operator and the cow riders would interact with the lock through the mobile app. So yes, this is the system flow of the whole process. This is our product which we are currently developing. It is for bicycles, and it basically has the same features which the application for mother dairy requires, but it's just different in shape and size, right? So we are providing IP65 lock body for this, and strong 12 steel rod. It has a sleek, elegant look, and there are options for emergency passcode also through these buttons. The passcode can be a pin 1234, or it can be Morse code, or it can be letters also. So we are better in the sense that we reduce false alerts. We provide 2G network connectivity for remote places. Our mobile and web applications are fairly smooth, which ensure smooth GPS tracking. We provide customized solutions and assured battery life. So this is how our testing strategy would be, starting with design validation through 3D printing the prototype, mobile app, feature testing, mechanical tests to ensure durability of the lock, and onboard electronics test. So yes, for any queries, you can connect with me through the mail ID and the mobile app. Thank you. And I would like to thank NASCOM, the organizers, for really making it an incredible event, and also the jury for their time. Thank you very much.
Thank you, Prateek, and best wishes while you work on it.